Hello, everybody. So sorry I was having technical difficulties this morning, but don't worry, this video will be the same thing that we would have done together if I hadn't had those problems. Let's start out by reviewing our homework, which your homework was to make number bonds. So since I'm here just me, I'll show you some number bonds. And I'm actually going to see if I can try to trick you guys. I don't know if it'll work or not, but I'm going to do 3 number bonds that are correct, but then a number bond that's not correct. And let's see if you can find the mistake that I purposefully make. And each time I do a number bond, I'm putting my hole at the top. And I'm going to choose the same hole actually. And I'm just going to do 4 number bonds. My hole is 11. And then there are 2 parts that should equal 11. I'll choose 10 and 1 for my first number bond. 5 and 6 for the next. 7 and 4 for the third number bond. And 8 and 6 for my last number bond. So which one is incorrect and why? Well, the 2 parts always need to equal the whole. Does 10 plus 1 more give me 11? Yep. What about 6 and 5? I will use my counting on strategy and make sure that 6 plus 5 gives me 11. So what comes after 6? 6 is like the starting point. So we start counting on after we move off of 6. Let's see, after 6 comes 7, 8, 9, 10, 11. Did it take me 5 jumps to get to 11? Yep. That one is correct. What about the number bond with 11 as the whole and 7 and 4 as the parts? Again, use the counting on strategy. What comes after 7? When you're doing counting on, you can think of playing a game on a board where you have to move on the different numbers with your game piece. So my game piece is on the number 7. And I will start counting after I move off of the 7th square onto the next square. After 7 comes 8, 9, 10, 11. So 7 and 4 does make 11. But 8 and 6, that does not equal 11. That equals 14. Remember, with number bonds, we also get to write 4 different true math equations. 2 plus sentences and 2 subtract or minus or take away sentences. 1 plus 10 is 11, for example. Switch those numbers around. The commutative property tells me that my answer remains the same. The whole is still 11, no matter where my parts are in the equation. When we subtract, we always start with the whole. The 11, we start with that one both times. And then 11, take away the part of 10, will give me 1 left over. And 11, take away the part of just 1, gives me 10 left over. Now with number bonds and tape diagrams, which we are learning about tape diagrams today, you'll see some similarities and some differences. They help us to do the same thing though. They help us solve word problems. They help us make sense of numbers, parts, and wholes. So if I continue with the same number bond, one of the ones we just did together, where 11 is made up of the parts 7 and 4, which one of these 2 parts is the bigger number? 7 is bigger, and 4 is the smaller part. Tape diagrams really help us to see which part is bigger and which part is smaller. So we do have to be careful when we draw tape diagrams that a bigger number gets drawn with a bigger part. Now, we call it a tape diagram a little bit because it looks like a piece of Scotch tape. And the same thing applies. Number bonds and tape diagrams, the whole comes at the top and the two parts will be underneath. And I need to be careful that my two parts are equal to the whole. I've got a bigger part, which is 7. So it's a bigger piece of tape. I might fix it just a little. Yeah, I think that looks good. And then I have a smaller part, which is 4. I write the number 4 inside the smaller part that I drew, and I write the number 7 in the larger part. 7 and 4 make 11. In fact, what do you notice when I look at the size of the pieces of tape? When I look at the size of the piece of tape, that's 11. And these two pieces next to each other, 7 and 4. Yes, they are the exact same size. That is what we'll be working on today, is tape diagrams. In fact, I have a little video I can show you that will explain just a bit more how tape diagrams help us when we're solving word problems. So it's with our friend, Scoop.
Hello. Today we're going to do some first grade addition with my dog, Scoop. Before we do that, we're going to read a comic called The Adventures of Math Boy and Math Girl vs. Mr. Grumpy Math Guy. Grumpy Math Guy says, if you kids can read, then you kids should get story problems right every time. So Grumpy Math Guy thinks story problems are easy. Well, Math Boy says, I love to read, but story problems are still hard for me. Math Girl's thinking. Math Girl says, think before you ink. Drawing bars to match your story helps you figure out parts or the whole. And Math Boy thinks, 2 parts and a whole, that sounds like a number bond. Woohoo! And Math Girl thinks, bond, number bond. So, on the advice of Math Girl, we're going to draw what's called a tape diagram to match your story problem. And a tape diagram is just a different way of organizing the pictures that you know how to draw for math. We know how to draw a 10 frame, but this is just a more sophisticated version of that will eventually help us solve any kind of problem. So when I read the story problem, I'm going to try and draw pictures to match it. So Lee saw 6 squash and 7 pumpkins growing in his garden. So I think we have 2 parts. We have 6 squash and 7 pumpkins. Okay, and I'm going to draw my 6 squash as 6 circles. 1, 2, 3, 4, 5, 6. Now I'm not going to draw them in groups of 5 anymore. Now the difference between a drawing and a tape diagram is I want to box this in. It's like I'm unrolling a piece of tape. I make a bar that is 6 big. I actually like to draw a starting line when I make a tape diagram, so I know where to start. When I run a race, I want to start at the same place. Now I know there are also 7 pumpkins growing. So I'm going to put a little S for squash, I'm going to put P over here for pumpkins, and I'm going to use X's for pumpkins, and I'm going to draw 7 X's. And you should notice that my bar for pumpkins is slightly bigger than my bars for squash, because 7 is a little bit bigger than 6. The size of our bars should match the size of our numbers. Well, now this really reminds me of a number bond. I want to know how many the whole garden has. That would be my question mark. So I always put a question mark in what I'm trying to find. Well, this really reminds me of a number bond that we've been working on all year. I don't know the whole, but I know the two parts. So now I can write a number sentence to match this. I know that 6 plus 7 equals the number we're looking for. And I can use any strategy I want. I can count on. For me, I'm going to make 10 because I think that's easiest. I know 6 and 4 make 10. And then if I've taken 4 away from 7, there's 3 left. So 10 and 3 make 13. And in this case, it's 13 vegetables. So I'm drawing a bar to match my story. My story could look different. Let's look at a different story using similar numbers. Okay? This time, Lee saw 6 squash and some zucchini growing in his garden. Okay? So I know my garden is going to have 6 squash, so I start by drawing my starting line. I'm going to make my squash circles, and I'm going to draw 6 of them. Again, I'm not making a 10 frame anymore. And I'm going to cup these in with a bar, write the number 6 and the letter S for squash. But here's the problem. There are some zucchini there, and I don't know how much zucchini this is. So I'm going to make about an equal sized bar, because I really don't know what goes in here. So I put a question mark in there. I'm going to label it Z for zucchini, and I still have one more piece of information, that there are 13 vegetables total. Since I know that's the total in my garden, that's worth the entire 2 bars put together. It makes 13. Again, this really reminds me of my number bond. I have 13 as my whole, 6 as a part, and I don't know what my other part is. So I know when I have a whole and a part, I'm going to do subtraction. 13, take away 6, equals my missing number. I can also write this as a missing add-in problem. 6 plus somebody makes 13. Both of these sentences are exactly the same. They're related. Okay? So my strategy is going to be to take from the 10. Because when I look at 6, I know I can't take from the 3 ones, so I'm going to take from the 10. So I'm going to do my math over here real quick. I'm going to do 10 minus 6, which means 4. But since I still had that 3 that I didn't take away from, I've got to add it back. So I know 13 minus 6 makes 7. So there would be 7 zucchini left in the garden. So all drawing these tape diagrams does is it really sets me up to be able to make sense of the problem. I think story problems are hard, but if I can draw a picture to look at it, it makes it easier. Let's check out what Scoop has to say. Scoop says, drawing a picture in the snow helps me figure out what math to do. So be like Scoop and draw a tape diagram to solve your word problems. Have a nice day.
All right, I love that video. And I love how they compare tape diagrams with number bonds. So every time that we solve a word problem, we don't have to just pick one. We can think of both, especially since this will help us to be sure we're doing the right strategy and getting the right answer. So let's practice with our own tape diagrams. And you guys actually have this uploaded into the Google Drive for Wednesday in first grade. When we have tape diagrams, again, we have the whole made up of 2 parts. And usually there's a bigger part and a smaller part. And it's very important that we draw smaller numbers as a smaller part. And just like we saw in the video, to help us, we can even draw circles or X's. Here I have 4 circles, and that helps me to make my part of 4 the correct size. And if I have 5 X's, it will help me to make this bar just a little bit bigger, since 5 is just a little bit bigger than 4. So what do we notice about tape diagrams? Well, you can add the 2 parts together to get the whole. You can also start with the whole and take away a part and get the other part. So number bonds and tape diagrams both help us with doing that. For example, 6 plus 2, the parts are 6 plus 2 and they equal the whole of 8. So that is my number sentence. 6 plus 2 equals 8. What else? Well, if we are missing one of the parts, tape diagrams can help us with that too. So 7 plus another part will give me 10. 7 is a pretty big number. I can even make 7 X's to show me just about how big this bar in the tape diagram should be. So there's 5 X's, 6, and 7. 10 is a bigger number than 7, so the size of the hole will be a little bit longer than 7. And then let's use the counting on strategy. 8, 9, 10. It only took me 3 counts to get to 10. I will draw 3 circles in that smaller part of the tape diagram. 7 plus 3 equals 10. But you can also use subtracting. 10 take away 7 is 3. So just like with number bonds, you can have 2 adding sentences and 2 takeaway sentences. Now here are word problems that are usually very tricky when they have more than or less than. These are some of the key words that I want you to pay attention to, such as how many more or how many less. For example, look at the larger quantity and pretend the word problem says, Miss Brown has 10,000 cookies. But Andrea, a smaller quantity, only has 5,000 cookies. And the question would be, how many more cookies does Miss Brown have? And that is called the difference. I won't take the large bar and the small bar and add them together. I want to know how they are different. Or my word problem could say, Andrew has 10 dogs, but Alice only has 6 dogs. How many less dogs does Alice have than Andrew? And again, we're looking for the difference. The difference is the answer of a subtracting problem. But of course, you can use adding to find the answer too. Let's look at an example. 6 more than 7. In my tape diagram, I have drawn the number 6. And again, you can put circles inside the bar to make sure that the size of that bar is correct. And we wouldn't want it to be too small or too big. So 6 circles. 6 more than 7. Right next to 6, we'll draw another bar for 7. And we can put 7 X's inside. We can add these together. 7 plus 6 equals 13. And then we read it out loud to see if it makes sense. We go back up to the top. And what were they asking us to do again? 6 more than 7 is 13. 7, 6 more, 13. Yes, that makes sense. Okay, what about 3 is 9 less than? So I draw a bar and the size is 9. 3 is 9 less. So I draw the number 3 size bar right next to 9. And I add them together. 3 plus 9 equals 12. Does this make sense? Let's go back up to the top and see. What was the question they wanted? 3 is 9 less than 12. So if I start with the whole of 12 and I take 9 less, I'll get 3. That does make sense. 12 and 9 less does equal 3. Okay, let's see if we can practice this a little bit more on our own. I've got 2 parts and they are equal to the whole. So we have 5 and 9. Add these together and we get 14. The whole is 14. I will skip number 2 and let you do that one by yourself. What about number 3? 6 plus 6, those are doubles. 6 plus 6 equals 12, yes. And you notice the size of the parts are the same because the addends, the numbers that we are adding, are the same. Can you give me a subtracting equation based on this tape diagram? Remember, we have to start with the whole. 12 take away 6 is 6. So doubles helps us when we are adding and when we are subtracting. Number 4, do that one on your own. What about number 5? 9 and 4. Which one of those numbers are the bigger? Is 9 the bigger part or 4? 9. 9 and 4 are next to each other. We are adding them together. They will equal the whole of 13. 13 is the same as 9 and 4. And I'll let you do number 6 on your own using the counting on strategy. Number 7 and 8, you got this. But can we use tape diagrams with 3 numbers? Let's give it a try. Now, how many parts do we have? 3 parts. And again, you notice that the size of the bar 2 is smaller because 2 is a smaller number. Okay, am I subtracting the parts? No. Adding them together to equal the whole, which generally the whole is on top, but it's okay that this whole is on the bottom. They can show us that we're starting at the same starting line and we're ending at the same ending line. Okay, I'm ready to add my 3 parts together. 2 and 8 make 10. So I'll just write myself a little note to remember the first 2 addends make 10. And then if I have to add 10 plus 4, I know that is 14. To do the next equation, number 10, remember to use doubles to help you. Do you see the doubles? The 2 numbers that are the same? The doubles are 4 and 4. And let's practice quickly with our doubles facts. Doubles facts involves counting by 2s. So 1 plus 1 is 2. 2 plus 2 is 4. And you can find doubles facts that, like I said, count by 2s. 2, 4, 6, 8. I have 4 fingers. 4 plus 4 makes 8. I found that out by counting by 2s. All right, so 4 plus 4 makes 8. I've added this part and this part together. What else is missing? What's the next part we need to add? 5, you got it. 8 plus 5, I can use the counting on strategy. My game piece is on the number 8, and as soon as I move off of it, I start counting on. So after 8 comes 9, 10, 11, 12, 13. Why did I use 5 fingers? Why did I stop when I said 13? Because we're adding 5. Hello, Wall. The answer is 13. 13 is the whole. All right, so you guys can use tape diagrams to make adding 3 numbers that much easier, especially if you kind of keep track like Ms. Brown did. What Okay, I added the 6, I added the 3. I still need to add the last part, which in this case would be 1. So your assignment goes to this page and you're done. But your last job will be to use tape diagrams and number bonds to help you solve word problems. So again, this screen that I'm showing you is what you should do today for your classwork. And then for homework, I will put this as a link into Google Drive, and it's word problems. Looks like we are doing addition, so we don't have to worry about subtraction, just addition. I will show you number 1 and number 6, but then let's have you try 2, 3, 4, 5 on your own. Let's read number 1. There are 6 chef assistants and 2 servers. How many staff are working there? Oh, we should read the beginning, which says, Chef Jennifer works at the school cafeteria. So picture the school lunchroom in your brain, because making a mental picture really helps when solving word problems. The question is, how many are working in the lunchroom or in the cafeteria? So I know that they said we had 6 and 2. Question is, how many are working? What does the 6 mean? Let's check. In the video, I learned it's helpful to label. 6 means chef assistants. Okay, so let's do a C for chef assistants. 2 means the servers, so I can do an S for servers. All right, this will help me to know how to draw a number bond and a tape diagram. So I know I have 6 and 2. 6 people work as assistants and 2 people work as servers. But the question was, how many workers are there? The workers would be the whole. It's the same as if I said I have 6 cookies and 2 brownies. How many desserts do I have? Desserts is like the big category, and these 2 examples are just details. So that's what helped me to figure out that I'm actually looking for the whole. I'm looking for how many workers. Let's draw a tape diagram. Here's my starting line. I'm going to draw a nice big tape diagram to mean my whole, and that's the question mark. Then I have 6 chef assistants, so I'll draw 6 circles. Okay, and I'll put a C for chefs. And then when I have 2 servers, I will draw 2 X's and label it with an S. And I can use addition. 6 plus 2 equals 8. So the answer for how many workers, the workers are 8. Let's try to make that number a bit clearer. And the last one for us to do together would be number 6. Write the addition sentence that fits this. Jennifer prepares 3 new recipes for the next month. On top of the original 9 recipes she has a total of 12 recipes. So I am going to write an addition sentence, but I'm also going to draw a tape diagram. I've got a total of 12, so 12 is the whole. And we have 3 recipes and 9 recipes. So again, 3R, R is for recipes. 9R, R is for recipes. These are the parts, and 12 is the whole. So let's make a starting line and a finishing line. I will draw 1 big bar for the whole of 12. And my 2 parts, which equal 12. 3 is a little smaller than 9. Well, it's kind of a lot smaller than 9. All right, there's my tape diagram, and my addition sentence, which is what they would like me to write, is 3 plus 9 equals 12. All right, guys, thanks for watching, and thanks for putting up with Miss Brown's crazy technology. Hopefully we won't be having those problems again. I will actually see everyone tomorrow morning, first graders at 10, second graders 10:30, third graders 11, just for a little bit of reading and writing together from our packets. And then we'll see all of you at 1 o'clock, where we'll start learning about careers for Career Day. Take care, everybody. See you tomorrow.